Hi, it's Cisco CCNA in 60 days. Paul Browning here. The book's version 4 if you want to grab a copy on Amazon. Please subscribe to the channel if you haven't already, because you'll see all the other videos, and we've got a ton of courses. I don't know how many, hundreds or thousands of hours by now of courses and videos. Software defined networking, network programmability. It's day 50. So this is a new topic, or certainly it was briefly mentioned before, and now it's full on exam topic. Do all the stuff you've been doing every other day. Start at day 0 if you've found this video by accident. So SDN for short, network programmability. We're going to talk about what it is, what it does, and what you need to know for the exam. There's some books will really help you study and successfully pass the exam on your first attempt, saving you a lot of money. So check those out. The links are in the description. And without further ado, we'll get on with the lesson. So we're going to go through software-defined networking and network programmability. This area has really been beefed up in the 2020 version of the CCNA. So you may be familiar with some of the concepts from the last exam if you did it. Otherwise it's all going to be new, but this is the future. If you're interested in learning more, please check out the DevNet Associate exam which Cisco offer. It's one of their CCNA level exams. There's only 3 left now: CyberOps, DevOps and the standard routing and switching. Come over to howtonetwork.com if you want to view some sample videos. So SDN is the catch-all term. It's basically, instead of us as the network administrator doing the command line interface and configuring each device separately, we're moving the paradigm over to a software control of our network, and I'll go into more details in a minute. So this is the new model. This is the new paradigm. If you're working in a large company, you may already be using it in some form or other, or definitely in a data center. Please check out the Cisco pages for Cisco DevOps, software-defined networking, and their software tool, which we'll go into in a bit. So this is what we're used to now. Is the network administrator, say you've got to change an access list, and all these devices go out to, say you've got a firewall here, and there's some rule on the firewall, and then these devices all connect to your firewall for whatever reason. So you've took a new customer on, and there's an ACL going through to these devices here. So what you've got to do is configure all the lines on this device here. Obviously save the changes. Then you've got to log on to this device, then this device. Now say you've got plus another 7 devices that would have to be configured. That's you spending quite a significant amount of the day. And say for example you configure it here, but over here you missed off one of the lines, or just because we're humans, you've made a configuration error here and here. All of a sudden you've got problems on this part of your network, and obviously you could have carried on making that mistake. So if you've worked on any device where it's command line, you'll know the pain of this particular issue. So after software defined networking is implemented, usually using a GUI, and there's other parts that go in with this, but usually using a GUI, you will configure the network controller, and then it will push the changes. Obviously it does a whole lot more than just pushing changes. It can do network health, security, policies for various devices that are configured into different policy groups. We won't need to know that for the CCNA though. As I said, check out the DevNet if you want to learn more, and I recommend you do. So this is obviously a lot easier for us because you can the controller can check for device for configuration errors also, and you're doing the drag and drop or ticking and unticking various menu items. So sorry, this should have slid in afterwards. So for example, if you're getting a configuration, this is a Python script. You don't need to know Python for the new exam. You would need to know it for the DevNet certification. So a small file has been written and it's pulling off a configuration file. It's saying check all the devices for the configuration. It would then be pushed to the devices, and here's the validation that comes back, and it's checked the whatever files you've configured the program here to do, and you can see it's passed whatever tests you've required. So basically it's making life a lot easier for you. It's removing the chances of human error also. We covered this before, and this is definitely going to be covered in the exam. You've got the control plane, which is the device brains. Routing happens here, your address resolution protocol. You've got the data plane, which is also known as a forwarding plane. This actually switches your packets across the network. There's a management plane. This is used to manage the devices. So SNMP, SSH, you would be configuring the devices. You need to know all three of these for the exam and also what they do. And bear in mind, some of them will have more than one term. So it could say forwarding plane or data plane. This is an image of how it all works. Please feel free to pause the video, but you can see we've got the data actually being pushed across the network. This would happen after the intelligent part has taken place. Routing decisions, check your net. This is obviously for OSPF. Check your neighbor table, your link state database, IP routing. EIGRP would have different tables. And static routes still would check the routing table. And then your management plane here, where you'd log in, do your configuration, or you could have a GUI for your SNMP. So this paradigm is still present in the majority of networks, but obviously we're moving on to the software-defined paradigm. So I've kind of split this up now, where you've got the data plane where the message is being pushed, but we need to know where to send in by the brain. So the device planes, including your management plane, which I didn't show in the diagram, is within all devices, and it's separate. So as I said before, you configure this switch, you configure that switch, you configure this switch. So the SDN controller, you will be responsible for this device here, and then the control plane will be pushing whatever changes are necessary over to each device, and that will take care of the forwarding. So the SDN controller, it's an application in the SDN that manages the flow control. This is called intelligent networking. There's a few paradigms depending on what sales literature you read. So it'll be different for Juniper, it'll be different for Cisco. They'll have their own particular terms for their marketing spiel. So they've got their own software that is linked to the controllers. There's some open source, and then there's some vendor specific ones. Alright, I think in the exam they mentioned, I'm going to talk in more detail here, so just bear this in mind. We've got our northbound API here, and then we've got our southbound API here, which is interfacing with each of our devices. The API, I'm sure you've heard of it before if you've got a smartphone, application programming interface. So this allows our hardware and software to interface with one another. Southbound interface could be an exam question because it's in the syllabus. So this controller communicates with the network devices. If we go back to the devices here, you can see what's going on. So the devices sit below the controller. So the API is designed to allow the data exchange. Now in the next presentation, I think if that's the order correctly, we talk about JSON and other ways of allowing this to actually happen. You've got a few options. Have a look through the Cisco. If you go to cisco.com and then you check out the DevNet stuff, you'll see all of the videos and presentations which will make a lot more sense. Now the northbound interface opens the controller, allowing data and functions to be accessed by programs. So if you wanted a specific function to take place or something to happen that's unique to you, you could have this programmed if the vendor allows access to the code. The big thing that Cisco are running is the Cisco DNA Center. So I recommend you Google this term, and then they've got loads of resources where you can just play the informational videos. There's white papers also. I only say this because I'm going to be repeating a lot of the stuff that's on their website, so you're best to get it from the source. So this is the GUI I mentioned before. So you would be on your desktop, you would remote in to where this piece of software, your network device that runs the Cisco DNA Center, has to be compatible, which is where the price comes in and your licensing. And you've got all the different options. So you would go into your assurance policy, etc. And you can make your changes here, and then this would be pushed to, this is the actual device that you're on, sorry, and then this would be pushed to your various devices. So your routers, switches, servers, and wireless devices, and so on. So the SDN controller resides on the Cisco DNA Center appliance. There's only a few devices. This will obviously change as the months go on that support this particular model of networking. It has to be enabled. You can't just download it onto your low-end switch or router. The DNA Center functions, you can't see it here, but you'll see it when you go to the Cisco website. These options here are reflected into your policy, automation and assurance. These are the three main areas. So your policy assigns devices to various groups, which I showed you before. So you would have various devices into various groups. Automation deploys updates. It would verify the updates and then push, say it's an iOS update and patching a security problem, it would push it to all your devices simultaneously. And then your assurance provides you with data in real time and historical, where you can see performance, any issues, and any potential issues. It's very robust and powerful. This is a screen capture from Cisco.com showing you some more information. It's just an infographic. In the exam, they do mention REST-based APIs. If you've got any programming experience, you'll be familiar with this already. We're removing the control plane logic, which we just talked about, control data and management earlier, to the computer resources. So this is, as I said, it's changing the paradigm from the actual devices to the controller. So it's making our life a lot easier. The mobile, say it's a mobile application here, the request goes and response goes through the API. The API communicates with your devices. So if you're talking about being another paradigm, the user checks the menu, sends the or gives the order to the waiter. The waiter then forwards the order to the kitchen. Pizza's returned from the kitchen and then delivered to you in an understandable fashion. So you obviously, if you're at a restaurant, you're not going to want to go into the kitchen and cook yourself a pizza. So this is the type of output you would see if you were using an API. You can obviously get into the coding side of things, and if you're going for the new version of the CCNP or the DevNet Associate, you'll be expected to learn some Python. So there's a couple of things I think they could ask you about in the exam. I talked about the REST-based API. I should have had this floating in, sorry. So these are designed to leverage existing protocols. There's a certain requirement if it's going to be considered as REST-based API. So it has to follow a certain architectural style of development that consists of rules and constraints. There's 6. 5 you have to have, and then the final one, number 6, is an optional. So it doesn't have to be there, but it can be. Again, sorry, I meant these to float in. The first one is it needs to use a uniform interface, and feel free to pause the presentation. So the resources should be uniquely identifiable through a single URL, only by using the underlying methods of the network protocol. So delete, put, and get. You may be familiar with these if you've looked into HTTP, especially if you've used Wireshark. Some of them are also associated with FTP. So that's the first one, uniform interface. Second one, it has to be a client-server based model. So there should be a clear delineation between the client and the server. The UI and request gathering concerns are the client's domain. Data access, workload management, and security are the server's domain. By the way, I think they're going to only ask you about these 6 requirements. I don't think they're going to go into this kind of information in the exam. So just the 6 headings. And stateless operation. So they'll try and catch you out by putting stateful, which is not one of the requirements. So client-server operation should be stateless. So any state management that's required should take place on the client, not the server. So what was that, number 3? Number 4, RESTful resource caching. All resources should allow caching unless explicitly indicated. Number 5, it has to be layered. So REST allows for an architecture composed of multiple layers of servers. And then number 6, which is the option. Most of the time a server will send back static representations of resources in the form of XML or JSON, which we talk about in another presentation. Only to give you an overview, and our CCIE talks about that. So when accessing a resource from a Cisco iOS XE API, so this is the one that supports our DevOps and the Cisco software, it goes through a request and response process. Each request includes the details that need to be processed by the API implemented on the network device in order to send a response. Now, I'll give you an exam warning. I can't tell you what's in the exam, and I can't tell you what was in it when I took it. You need to match what happened. So, say to create data, you need to match the CRUD operation with the HTTP method. So, a create command, if it's been sent using HTTP, it will, if you capture a packet, it will say post. If you're just doing a read in HTTP, that's a get. Now there's 2 types of updates. There's a put and a patch, which is this is a small change. And then finally, easy to remember, a delete is just a delete. So there's a good chance you'll have a drag and drop type question or multiple choice, multiple answer. Alright, so new paradigm, you must know all this stuff, and anything that's new in the syllabus, you've got a high chance of being tested. And also there's an entire block, I think it's number 6 or number 7 in the syllabus, all about network automation. So we've done the first half here. The second half is in the JSON configuration management presentations.